Welcome to this Nexus Industrial Memory presentation, the subject of which is designing removable memory into a product, the top-level design considerations. So let's start by setting the scope of this presentation. By product we mean an embedded system, and that can be anything from an IoT-enabled consumer device through to the control systems of a wind turbine. As for the memory type, we're talking flash, of which there are two types used in embedded systems, NOR and NAND. Here is a comparison of their properties. NOR flash is very popular amongst applications requiring code storage, such as home gateway and set-top boxes, because of its ability to support execute-in-place applications and its low standby power consumption. NAND is more suitable for data storage applications that do not require execute-in-place support. Of these, NAND is by far the most commonly used. So let's look at why you would use a removable memory device in an embedded system. In no particular order, the top 5 uses of removable memory devices are: to boost internal memory, user authentication, data storage, device configuration, and for upgrading a device with new software or firmware. So these are the main uses. Let's consider some applications and their associated design considerations in terms of value of the end product, the environment in which it operates, security aspects, and how long the product needs to be in service for. Let's start by considering some typical household goods. Product value will typically be up to about £2,000. The environment is not particularly harsh for most applications, though washing machines will see high vibration levels. Security is generally considered a low priority, though there are growing concerns over how hackers can gain access to home networks through IoT-enabled smart devices. Life expectancy of the product will typically be between 5 and 10 years. The frequency with which the memory device is inserted and removed, and how long it is in place for, will vary depending on the application. This needs to be a design consideration because there are limits to how many write and erase cycles you can expect from a removable memory device, and they will have a rated number of insertions and removals. These considerations apply to all other applications discussed in this presentation, but won't be repeated. Another application is a vending machine, and as an aside, it is worth mentioning that one of Nexus's biggest and longest standing customers is Mars Drinks. The product value is typically up to £2,000. The environment is generally not harsh. Security is a low priority. Compared to household goods though, a vending machine's expected life is 10 to 20 years, during which time it must deliver a return on investment. Removable memory devices will typically be used infrequently and only in place for a few minutes at a time. Another application for removable memory devices is in the automotive sector. The product value, i.e. the cost of a new vehicle, is high. The environment is generally not harsh. As for security, that is a medium to high concern as we move towards vehicles with greater levels of automation, but which are themselves part of a network. For example, in July of 2018, it was reported that hackers had access to Jeep Cherokee via its internet-connected entertainment system. Interestingly, Fiat Chrysler, owner of Jeep, provided owners with a software patch that was supplied on a USB stick. Expected product life will be in excess of 10 years. Removable memory devices for software updates will typically be used infrequently and only in place for a few minutes at a time, but the port itself could see regular use for the playing of audio files. Removable memory devices are also used in the renewable energy sector. Here the product value is in the millions of pounds, and utility-scale wind turbines, for example, cost between 1 million and 2 million per rated megawatt of power generation capability. The environment is harsh, and solar farms, and particularly wind farms, are sited in remote locations. Security is of a medium to high concern, as renewable energy farms are increasingly becoming part of the UK's and many other countries' infrastructure. The life expectancy of a wind turbine is about 20 years. Uses of removable memory devices include user authentication on solar farms, in which case the device will only be in place for a few hours at a time, during maintenance work for example. On wind farms, removable memory devices are in use to provide configuration data, such as operational parameters, and will be permanently installed. Another example is in the military sector. However, we state now that USB sticks and thumb drives are not technically allowed in this sector. The USA's Department of Defense, for example, banned the use of USB sticks in 2008. The value of the product, i.e. the vehicle, is high. The environment is extremely harsh. Security is high, and product life can easily exceed 20 years. As for the frequency of use, when removable memory devices are used as crypto ignition keys, they will see daily use. As mentioned, USB drives are not allowed in the military sector. It is worthy of note, though, that Nexus Industrial Memory has been supporting the military sector with non-USB format devices for more than 30 years. For all applications discussed, product life was a top-level consideration. Let's therefore discuss removable memory formats in terms of their longevity. USB is of course the form factor with which we are most familiar. It first appeared in 1997. However, multimedia cards, MMCs, appeared circa 2 years before USB flash as a compact storage solution for use in digital cameras, mobile phones and PDAs. With the creation of the Secure Digital Music Initiative intended to help combat music piracy, the Secure Digital SD format was released in 1999. The first iteration was the Secure Digital Standard Capacity SDSC. In 2003, a smaller form factor SD was introduced known as the Mini SD, marketed mostly to the mobile phone industry for its compact size. Production ceased in 2008 because of the success of the Micro SD, introduced in 2005. Standard and Micro SDs then followed parallel journeys with regards memory expansions. First high capacity HC, then extended capacity XC. Ultra capacity is due for release soon. The take home from this is that if MMC had been designed into a product in the mid to late 1990s, the form factor's obsolescence 2 years after its launch may well have caught out the product's OEM. Similarly, Mini SD would not have been a good horse to back either. However, 3 data key bespoke form factor removable memory devices, a key, a token and a plug predate even MMCs and are still in production today. Let's consider the overall benefits of bespoke form factor devices. As mentioned, longevity is afforded. They are rugged and used in all of the harsh environment applications discussed in this presentation, as well as others. At up to 200,000 they are rated for far more disconnects than USB, which as mentioned earlier is just 1,500. Lastly, security is improved because unlike USB sticks and SD cards, data keys, tokens and plugs cannot be purchased through regular outlets. Understandably, the keys, tokens and plugs all have corresponding receptacles, so should someone find a device, it is unlikely they will be able to interface with it. So, in summary, removable memory is used in a variety of sectors and for different purposes. However, USB may not be the ideal or even an allowed form factor because of the product's value and expected life, its operating environment, security considerations, and the frequency with which the removable memory device will be used. Bespoke form factor devices are therefore a practical alternative to the more widely available memory sticks and cards, and we invite you to visit our website nexusindustrialmemory.com or call us on country code 44 1794 732 087 if dialing from outside the UK, or 01 794 732 087 if dialing from within. Thank you.